Now when you are adding and subtracting fractions and neither one of the cases, the smallest doesn't divide it evenly into the largest, or one or both are not a prime number, this is where we're going to use our ladder method. So again, remember the ladder method is you write the two numbers and you draw your little box around it. And you're going to divide out prime factors. And because they're both even, I'm going to start with 2, and I'm going to divide it out of 42 and 18. And I'm going to be left with 21 and 9. And now I see 21 and 9 have a prime factor of 3 in common, so I'm going to divide 3 out of 21 and 9. Whatever's left goes underneath, so I end up with 7 and 3. 7 and 3 do not have common factors, so my least common multiple are going to be the numbers multiplied together on the outside. So I always like multiplying the side numbers first, which is going to be 6. Then the bottom numbers next, which would be 21, and then you multiply the 6 to 21, and that will give you your least common multiple of 126. So now this is using the ladder method. I found my least common multiple is going to be 126. Now, the nice little thing about the ladder method, it gives you a little trick on how to find your multiples. I'm looking at 42 and thinking, well, what do I multiply 42 by to get 126? Well, the ladder method always kind of indicates it by the diagonal bottom number. The diagonal bottom number to 42 will give me the factor I need to multiply by to get my least common multiple of 126. So now that I know that, I know what I need to multiply the numerator by. So I'm going to multiply 13 by 3 to get 39. And same thing with the 18. 18 times 7 will give me that least common multiple of 126. Whatever I multiply 18 by, I need to make sure I multiply the numerator by. So I end up with 35. And now I have the like fractions, so I can subtract and keep the sign of the higher number. And I see I can reduce because they're both even numbers. So please be careful, especially when you do all this work. Your final answer, if you don't reduce, it will be incorrect. So make sure you're thinking at the very end, do they have common factors, especially when they're both even numbers. Pause and try. Again, I like using the ladder method. I'm writing it off to the side so you can see the work that I did to find the least common multiple. So hopefully you came up with the least common multiple of 60. And now that you have your least common multiple of 60, again, the bottom diagonal number from 12 will give me the number I need to multiply the numerator and the denominator by. And the diagonal bottom number of 20 gives me the number I need to multiply by the numerator. Now I have my converted fractions, so I can add the numerators, and I see in this case it's going to reduce. And I see I reduced 2 out, and I still have 2 even numbers, so I need to continue to reduce until they no longer have common factors. So in this case, our final answer would be 7 over 15. Pause and try. So I'm using my ladder method here again. I'm putting it off to the side so you can see the work that I did to find my least common multiple. I find my least common multiple by multiplying the side and then the bottom, and I get that my least common multiple for 16 and 24 is 48. So now I know what the least common multiple is. Remember, the bottom diagonal number is going to give me the number I need to multiply the 16 by to get my least common multiple, and I know what to multiply the numerator by. And 2 to the 24, and now I see different signs. Different signs mean I subtract and keep the sign of the higher number. Now, whenever we're talking about adding a whole number to a fraction, remember that property of one rule. We can make that whole number a fraction. When we have two fractions being added together, we know we need to get a common denominator. So the common denominator will be the denominator of the fraction. So in this case, it will be 7. So I need to convert that 3 over 1 to have a denominator of 7, so I'm going to multiply the top and the bottom by 7. So I end up with 21 over 7, and then I plus the original fraction 6 over 7. Now that they're both have a common denominator, I can add the numerators, and I'm left with 27 over 7. Pause and try. Again, I'm putting that 8 over 1. I'm going to get a common denominator of 10 by multiplying the top and the bottom by 10. And I get 80 over 10. Pause and try. So again, put the whole number over 1. We're going to need to get a common denominator of 11. We're going to multiply the second fraction by 11 over 11. And here we have different signs, and we're going to subtract and keep the sign of the higher number. So you end up with 72 over 11. Now when you see fractions with variables in the denominator, they're rational expressions, and you need to get a common denominator to add or subtract these expressions. So the first thing you're going to want to do is get the common denominator for the numerical part, and then you get the common denominator for the variable part. But in this case, our variable part is the same, so the common denominator will have the variable x in it. So I really only need to find the least common multiple for the numerical part, which is the 12 and the 18. And again, we can use the ladder method here to find our least common multiple, which would be 36, and the x needs to be part of that least common denominator. So we're going to convert the fractions to have the denominator of 36x. And because the first fraction has x in it, I only need to find the number times 12 that will give me 36. So in this case, it would be 3, and whatever I multiply 12 by, I need to multiply the numerator by. So I end up with 33 over 36x. The second fraction I'm multiplying by 2 to get 36x, and I have to multiply the numerator by 2, and I get 14. So I get 14 over 36x. Now I have my like denominators, so I can subtract here, and I have 19 over 36x.